the thing is, in the Java world, it's either not so big or very big. There's no in between, or at least it doesn't get the amount of attention. But yeah, Log4Shell was a big one because um, first of all, props to the folks that maintain that, because I think there were only 3 active maintainers at that point when the thing comes out, and it's a small library that is used and consumed by a lot of bigger frameworks. So everybody was looking at, you're doing a bad job. It was just 3 guys that voluntarily maintained.
Welcome back, everyone. Welcome back to the next episode of simplyblock's Cloud Commute podcast. Today, I have yet another amazing guest with me, Brian from Snyk. Sing.
That's always the question, right? How do you pronounce that name? Is it Sneak, Snyk, Sync? It's not Sync. It's Sneak. Some people say Snyk, but I don't like that. And the founder once said it's Sneak, and it's actually an abbreviation.
All right, we'll get into that in a second.
So now you know. I mean,
yep. We'll get back to that in a second. All right. So you're working for Snyk. Yep. But maybe we can talk a little bit about you first, like who you are, where you come from. I mean, we know for a couple of years, but
that's always hard to talk about yourself, right? I'm Brian Vermeer. I live in the Netherlands, just an hour and a half south of Amsterdam. I work for Snyk as a developer advocate. I've been a long-term Java developer, mostly backend developer, for all sorts of jobs within the Netherlands. Java champion, very active in the community, specifically the Dutch community. So the Netherlands Java user group and adjacent Java user groups. Do some stuff in the virtual Java user group that we just relaunched. That I try to be active, and I am just a happy programmer.
You're just a happy programmer. Does that even exist?
Apparently, I am the living example.
All right, fair enough. So let's get back to Snyk and the cool abbreviation. Like,
yeah,
what is Snyk? What does it mean? What do you guys do?
It's what we do. First of all, we create security tooling for developers. So our mission is to make security an integrated thing within your development lifecycle. Like in most companies, it's an afterthought, like one security team trying to do a lot of things, and we have something in the pipeline, and that's horrible because I don't want to deal with that. And if all tests are green, it's fine. But what if we perceive it in such a way as, hey, catch it early from your local machine, just like you do with unit tests. Maybe that's already a hard job creating unit tests, but hey, let's say we're all good at that. Like, why not perceive it in that way? If we can catch things early, we probably do not have to do a lot of rework if something comes up. So that's why we create tooling for all stages of your software development lifecycle. And what I said, Snyk is an abbreviation. So now you know.
So what does it mean? Or do you forget?
So now you know.
Oh.
Literally. So now you know.
Oh, that took a second.
Yep. That takes a while for some people. Now, the thought behind that is we started as a software composite analysis tool, and people just bring in libraries. They have no clue what they're bringing in and what kind of implications come with that. So we can do tests on that. We can make reports of that, and you can make the decisions. So now at least you know what you're getting into.
Right. And I think with implications and stuff, you mean transparent transistence dependencies, stuff like that.
Yeah.
And I guess that just got worse with Docker and images and all that kind of stuff.
I won't say it gets worse. I think we shifted the problem. I mean, we used to do this on bare metal machines as well, that these machines also had an operating system, right? So I'm not saying it's getting worse, but developers get into more responsibility because let's say we're doing DevOps, whatever that may mean. I mean, ask 10 DevOps engineers. That's nowadays a job. What DevOps is, you probably get a lot of questions about tooling and that, but apparently what we did is tearing down the wall between old-fashioned developer creation and getting things to production, so the ops folks. So we're now responsible as a team to do all of that. And now your container or your environment, your cluster, your code is all together in your Git repository. So it's all code now. And the team creating it is responsible for it. So yes, it's shifted the problem from being in separate teams now to all in one team, that we need to create and maintain stuff. So I don't think we're getting into worse problems. I think we're shifting the problems, and it's getting easier to get into problems. That's what I
yeah. Okay, we're broadening the scope of where you could potentially run into issues. So the way it works is that Snyk, I need to remember to say Snyk and not Snyk, because
It's
now
fine.
it makes sense.
I'm okay with however you call it. As long as you don't say sync, I'm fine. Then
Now
you're
sync
actually
is
messing up letters. That's like,
yeah,
I'm good.
sync is different.
Yeah.
It's not awkward, and it's not Worcester. Anyway, so that means the tooling is actually looking into, I think, the dependencies, the build environment, whatever ends up in your Docker container or your container image. Let's say it that way. Nobody's using Docker anymore. um, um, and all those other things. So basically everything along the pipeline or the build pipeline, right?
Yeah, you can say that. Actually, we start at the custom code that you're actually writing. So we're doing static analysis on that as well. Might combine that with stuff that we know from your, let's say, all your dependencies that come in, your dependencies, transitive dependencies. Like, hey, you bring in a Spring Boot starter that has a ton of implications on how many libraries will come in. Are these affected? Yes or no, et cetera, et cetera. That we go one layer deeper or around that. Say your container images, and let's say it's Docker because it's still the mostly used. But whatever, like any image is built on a base image, and probably you streamline some binaries in there. So what's there? That's another shell around the whole application, and then you get into, in the end, for instance, your configuration for your infrastructure as code, as we call it, that can go wrong by not having a security context, or like some policies that are not met or something like that. Some pods that you gave more privileges than you should have because, hey, works on my machine, right? Let's ship it. These kind of things. So on all these four fronts, we try to provide tooling and test capabilities in such a way that you can choose how you want to utilize these test capabilities, either in a CI pipeline or on a local machine or in between or part of your build, whatever fits your needs. Instead of, hey, this needs to be part of your build pipeline because that's how the tool works. And I was a developer myself for backend for backend jobs a long time, and I was the person that was like, if we need to satisfy that tool, I will find a way around it.
Yeah,
Which
I
defeats
hear you.
Yeah, which defeats the purpose because at that point you're only like checking boxes. So I think if these tools fit your way of working and complement your way of working, then you actually have an enabler instead of a wall that you bump into every time.
Yeah, that makes a lot of sense. So that means when you say you started at the code level, I think simple like the still most common thing like SQL injection issues, all that kind of stuff. That is probably handled as well, right?
Yeah. SQL injections, path reversal injections, cross-site scripting, all these kind of things
Oh,
will get notified, and we will, if possible, we will give you remediation advice on that, and then we go levels deeper. So it's actually like, you can almost say it's like four different types of scanner that you can use in whatever way you want. Some people are like, no, I'm just only using the dependency analysis stuff. That's also fine. Like, it's just four different capabilities for basically four levels in your application, because it's no longer just your binary that you put in. It's more than
right.
that, as we just discussed.
So when we look at like the recent and not so recent past, I mean, we're both coming from the Java world. And you said you're also, or you were a Java programmer for a long time. I am. I think I mean, the Java world isn't necessarily known for like the massive CVEs, except Log4Shell, which,
Yeah, that was a big one.
right? Yeah,
I mean, the thing I think the thing is in the Java world, it's either not so big or very big. There's no in between, or at least it doesn't
right.
get the amount of attention. But yeah, Log4Shell was a big one because um, first of all, props to the folks that maintain that because I think there were only 3 active maintainers at that point when the thing comes out, and it's a small library that is used and consumed by a lot of bigger frameworks.
Yeah.
So everybody was looking at, you're doing a bad job. It was just 3 guys that voluntarily
Yeah, so
maintained.
for the people that do not know what Log4Shell was, so Log4j is one of the most common logging frameworks in Java. And there was a way to inject remote code and execute it with basically whatever permission your process had. And as you said, a lot of people love to run their containers with root privileges. So there's your problem right there. But yeah, so Log4Shell was, I think, at least from what I can remember, probably like the biggest CVE in the Java world ever since I joined.
Maybe that one, but we had in 2017 we had the Apache Struts one that
Yes, I
blew away our friendly neighborhood Equifax. But yeah, I think
Yeah,
these are
I'm
the
not talking about struts because that was like so long deprecated by that point of time. It was
sure.
they they deserved it. No, but seriously, yeah. True. The struts one was also pretty big. But since we are just recording it this on April 3rd, there was just like a very interesting thing. It was like 2 days ago, 3 days ago, like April 1st. I think it was actually April 1st because I initially thought it's an April's Fool joke, but it was unfortunately not.
I think it was the last day of March though, so it was
Was
not.
it last day? Maybe I
That
just saw it like April 1st.
could be.
To be honest, initially I thought, okay, that's a really bad April's Fool. So what we're talking about is the XZ issue. Maybe you want to say a few words about that, or want me?
Well, let's keep it simple. The XZ issue is basically an issue in one of the tools that come with some Linux distributions. And long story short, I'm not sure if they already created exploits on that. I didn't actually try it because we've got other folks that doing the research. But apparently, because of that tool, you could do nasty stuff as arbitrary code executions or things with going into secure connections. At least it comes with your operating system. So that means if you have a Docker image or whatever image and you base it on a certain well-known Linux distribution, you might be infected, regardless of whatever your application does. And it's a big one. If you want to go into deep, like there are tons of blogs of people that can explain to you what the actual problem was. But I think for the general developer, it's like, don't shut your eyes and like it's not on my machine. It might be in your container because you're using an
Yeah, I think
outdated image.
I think there's two things. First of all, I think it was found before it actually made it into any distribution, which is good. So if you're not using any of the like self-built distributions, you're probably good. But what I found more interesting about that this backdoor was introduced from a person that was working on the tool for quite a while, like over a year or so, basically getting the trust of the actual maintainers, um, and just sneaking stuff in eventually. And that is that is why I think tools like Snyk, or let's be blunt, some of the competitors are so important, right? Because it's really hard to just follow all of the new CVs, and sometimes they're not blowing up this big, so you probably don't even hear about them. But for that reason, it's really important to have those tools.
I totally agree. I mean, as a development team, it is a side effect for you, like you're building stuff and you don't focus on checking manually whatever is coming in and if it's vulnerable or not. But you should be aware of these kind of things. So
Right.
if they come in, you can make appropriate choices. I'm not saying you have to fix it. That's up to you, like, and your threat level and whatever is going on in your company. But you need to be able to make these decisions based on accurate knowledge
Right.
and have the appropriate knowledge that you can make such a decision. And yeah, you don't want to manually hunt these things down. You want to be actively pinged when something happens to your application that might have implications for your security risk.
Right. And from your own feeling, like in the past we mostly deployed like on-prem installations or in like private clouds, but with the shift to public cloud, did we increase the like risk factor? Did we increase the attack surface?
It's a yes. I think the short thing is yes. There are more things that we have under our control as a development team. We do not always have the necessary specialties within the team, so we're doing the best we can. But it means we've got multiple attack phases. Like your yes, your the connection with your application is one thing, but this one is if I can get into your container for some reason, I can use this even though some things in containers or some things in operating systems might not be directly usable, but part of a chain that causes a problem. So I can get in one, like if there's one hole, I can get in and use certain objects or certain binaries in my chain of attacks and make it a domino effect, basically. So
Right.
you're giving people more and more ammunition. So and as we automate certain things, we do not always have the necessary knowledge about certain things that might become bigger and bigger. Plus, the fast pace we're currently moving. Like tell me, like 10 years ago, how were you deploying?
I don't know. I don't remember. I don't remember yesterday.
Nah, but I mean, probably not 3 times a day. Like 10 years
No,
ago,
no,
we're
it was
probably
certainly.
like deploying once a month. You have time to test or something like that. So it's a combination of doing all within one team, which yes, we should do, but also the fast pace that we need to release nowadays is something like okay, we're just doing it. The whole continuous development and continuous deployment is part of this. If you're actually doing that, of course.
Yeah, that's true. I think it would have been like about every 2 weeks or so. But yeah, you normally had like 1 week development, 1 week bug fixing and testing, and then you deployed it. Now it's like you do something, you think it's ready, it runs through the pipeline, and in the best case, it gets deployed immediately. And if something breaks, you're gonna fix it, or you in the worst case you roll back if it's really bad.
But but at the other end, say you're an application developer and you need to do that stuff in a container and you ship it. Um, are you touching your container or rebuild your container if your application didn't change?
Yes.
Prob-
Right? And not
Probably,
only not only that,
probably a lot of folks won't because hey, some things didn't change, but it can be that the image you base your stuff upon, or your base image, or however you may manage that, can be company wide, or you just pull something out of Docker Hub or whatever. That's another layer that might have changed and might have been fixed, or there might have been vulnerabilities found in it. So
yeah.
it's not anymore like, hey, I didn't touch that application, so I don't have to do a rebuild. Uh, yes, you should because other layers in that whole application changed.
Right, right. And I think you brought up an important other factor. It might be that meanwhile, like during the last or in between the last deployment and now a CVE has been found or something else, right? So you want to make sure you're gonna test it again. And then you have other programming languages. I'm not naming things here, but you might get a different version of the dependency, which is slightly newer. You're doing a new install, right? And all of that there's so many different things. Applications these days, even microservices are so complex because they normally need like so many different dependencies. That it is hard to keep an eye on that. Um, and that kind of brings me to my next question. Like, how does Snyk play into like SBOM or the software bill of materials?
Getting into the hype train of S bombs. Now, it's not just a hype train. I mean, it's a serious thing. The S for folks that don't know, you can compare the S bomb as your ingredients nutrition list for whatever you try to consume to stuff in your face. Basically, what's in there? You have no clue. The nutrition facts on the package should say what's in it, right? So that's how you should perceive an S bomb, as if you create an artifact, then you should create a suitable SBOM with it that basically says, okay, I'm using these dependencies and these transitive dependencies and maybe even these Docker containers or whatever. I'm using these things to create my artifact. And a consumer of that artifact is then able to search around that. Like say a CV comes up, a new log for shell comes up. Let's make it big. Am I infected? That's the first question a consumer or somebody that uses your artifact says. Like, and with an SBOM, you have a standardized. Well, there are 3 standards, but nevertheless, like multiple standards. But there's a standardized way of having that and make it at least machine searchable to see if you are vulnerable or not. So how we play into that? Yes, you can use our Snyk tooling to create SBOMs. For your applications or for your containers, that's possible. We have the capabilities to read SBOMs in to see if these SBOMs contain packages or artifacts or stuff that have known vulnerabilities. So you can again take the appropriate measures. I think the SBOM is great from the consumer side, so it's very clear what that stuff that I got from the internet or got from a supplier, because we're talking about supply chain all the time, from a supplier within stuff that I build upon or that I'm using, that I can see if it contains problems or it contains potential problems when something new comes up. And yes, we have capabilities of creating these SBOMs and scanning these SBOMs.
All right. We're basically out of time. We're not basically, we are out of time. But there's one more question I still want to ask. And how do you, or where do you personally see like the biggest trend? Could be related to Snyk, to security in general.
Oh, the biggest trend is the hype thing of AI nowadays, and that is definitely a thing. What people think is that AI is a suitable replacement for a security engineer. Yeah, I exaggerate now, but that's not. We have demos where we let a code assistant tool, a well-known code assistant tool, spit out vulnerable code, for instance. So I think the trend is 2 things: the whole supply chain, software supply chain, whatever you get into, you should look at one thing. But the other tool is that if people are using AI, don't trust it blindly. And I think that's for everything, for both stuff in your supply chain as in generated code by a code assistant. You should know what you're doing. Like, it's a great tool, but don't trust it blindly, because it can also hallucinate and bring in stuff that you didn't expect if you are not aware of what you're doing. So yeah,
I think that is a perfect closing. It can hallucinate things.
oh, definitely. It's a lot of fun to play with it. It's also a great tool, but you should know it doesn't. First of all, it doesn't replace developers that think. Like, thinking is still something an AI doesn't do.
Not yet, at least. All right. Thank you very much.
All right, man.
Time is over. 20 minutes is always super short, but it's supposed to be that. Or that way. So Brian, thank you very much for being here. I hope that was not only interesting to me. I actually learned quite a few new things about Snyk, because I haven't looked into it for a couple of years now. So yeah, thank you very much. And for the audience, I hope you're listening in next week. New guest, new show episode, and we're going to see you again.